So yes, this is domain modeling made functional. And let's see, here we go. Yeah, so I'm Scott WLASCHIN, and that's my Twitter handle if you ever need to contact me. I have a website, fsharpfunandprofit.com, which is about F#. I'll be using F# for the examples here, but in fact, these ideas apply to most programming languages, especially functional programming languages, but statically typed languages, really. So, okay, so people, what about functional programming? What is it good for? Most people think that functional programming is only good for mathematical things. And I'm going to try and show you that's wrong, not for mathematical things, but for interactive domain modeling and representing a domain model accurately. So this is different from what most people think functional programming is good for. So this is functional programming and domain-driven design, and I actually think they're a really good match. They work together very well. So I'm going to try and persuade you in this talk that is true. So, all right, so before I get started on the main part, I just want to talk about the importance of design. If you think about software development as a process, just like any process, there's an input and an output to the process. And we like to talk about the process part. We like to talk about coding and testing and our editors and our IDEs and our compilers and what's the best programming language. We love to talk about that stuff. But in my opinion, that is not the most important part of software development. I think the most important part is the input and output. And the reason is because there's this expression, if you have garbage in, you have garbage out. So if you have bad input, if you have bad requirements, you're going to have a bad program. And it doesn't matter how good your compiler is, it doesn't matter how good your tooling is, if your requirements, if your input is bad, the output's going to be bad. So the idea of this talk really is to reduce the garbage going in. If you have less, if there's less bad stuff coming in, you're more likely to have good stuff coming out. And that's what I'm calling design. So design is requirements gathering, it's understanding the problem, it's thinking about the problem, it's everything before you start coding. So think before you code. There you go. That's if that's one thing you can take away from this talk, think before you code. Right, so how can we do design right? So I'm going to borrow some techniques from Agile and also from domain-driven design. And what I'm going to borrow from Agile is this idea of rapid feedback. And the idea that, you know, the faster you can get feedback from people, the faster your cycles of development, the better things are because you learn faster. It's all about learning and making mistakes, but learning from your mistakes quickly. Now, from domain-driven design, I am going to take away the idea that there is a shared mental model. Everyone thinks the same way about the problem. Not that you don't have people thinking differently. Everyone thinks the same way, and that thing is also represented in the code. So that not just the people have it in their head, but the code also has the model in its head. So here's a little picture of what I mean. We have a shared mental model. We have the product people, we have developers, we have domain experts, we have users and customers and testers and user interface people. Everybody has the same shared mental model. Everyone uses the same language. Everyone has the same concepts. And this is the point. If you don't have a shared mental model, I think that the project is going to fail. This is the most likely way that projects fail, is because people do not agree on what they're doing. If people don't agree on what they're doing, I think that's a bad situation. So everyone has to agree on what we're building. And ideally, the code represents that too. So the idea is you put this shared mental model into your code. That's the domain model or the code as documentation and domain model. Everything that's important belongs in the code as well. And that way it never gets out of date. It's always in sync. So the common language that you use when you're talking to people is the same common language you use when you're writing code. So that's the basic idea behind domain-driven design. Now, at this point, most people say, that's a nice idea, but can you really make the code represent the domain? Is that even possible? because everyone knows that this is what code looks like. This is what source code looks like. Especially non-developers think this, but even some C developers think this is what source code should look like. But no, I'm not talking about this kind of source code. Let me show you the kind of source code I'm talking about. This is what domain-driven source code looks like in my opinion. So you have to guess, what is this code about? So this is F# code, but even if you don't know anything about F#, I think you can guess what's going on here, right? It's something to do with a card game, because it says card game right at the top. And all the things down the side, these are the vocabulary, these are the words that we use when we talk about card games, right? So we have our shared language, and anyone can read this, even non-developers. So let me just explain the syntax for people who don't know F#. Let me explain the syntax. The vertical bar means a choice. A star means a pair. So a card is a suit and a rank, a combination. We have a list type in F#, which is very nice. And then we see this arrow. This is a workflow or a function, and we're going to use this to represent activities or stories or use cases in the domain. So let me kind of dive into that a bit more. How do functions play a role in a domain design? So we're going to model all our activities with functions, all the verbs with functions. So here is a function which is dealing a card. So to deal a card, you start off with a deck in your hand when you're dealing, and then that's the input. And then the output is a card on the table, but also a different deck, because in functional programming, everything is immutable. So you can't modify the original deck. You have to make a clone of that deck, but with one card missing. So the output of this function also has the change deck as part of the output. So in F#, we would document it this way. We'd say to deal, the input is a deck, and the output is a pair of things. It's a new deck and a card on the table. So that's how we would document activities, not just objects, but actions. Similarly, if we want to pick up a card, we're having our hand that we're holding, and then we have a card on the table, and we pick up the card, and now we have a new hand. So the input is the original hand plus the card on the table, and after we've picked it up, we have a new hand, and the card on the table is not there anymore. So we would document it again. That's this activity would be documented as a function, and the input to the function is a pair of things, the original hand and the card, and the output of this function is the new hand, because we don't mutate it, we don't modify it. So that's how we document activities in our F# way of doing things. So here is our domain, and let me ask you some questions. First of all, do you think this is a reasonable amount of code to write to capture this domain? And I think most people say, yes, this is actually pretty good. The whole domain fits on one page. I don't have to go to 20 different files. I don't have to look in the documentation. This is actually code, and it tells me a lot of things which are important about the domain. Do you think a non-programmer could understand this? And I have done workshops where the people involved in the workshop are not just developers, but also product managers and domain experts and so on. And one comment I really heard was, this is great documentation, but where's the code? So they didn't even realize that this was code, which is kind of cool. Do you think a non-programmer could provide useful feedback? So if I'm showing this to somebody and I made a mistake, do you think that a non-programmer could give me feedback and show me where I made a mistake? And there's actually a deliberate mistake here. Anyone see what it is? Yeah, I think most people are going to see, yes, the ace. That's right. The ace is missing. So that's an example where even if you don't understand F#, you can notice something like this. And this is the kind of feedback which is really useful that you can get from people who are not programmers. Like an expert in card games would totally notice this straight away. Right, so getting feedback during the design stage is really, really useful. And in agile development, the idea is we have very short sprints. We try and do things every few weeks or every week. But if you can get feedback in minutes, that's even better than getting feedback in days or weeks. So let me show you an example of how you might get feedback when you're doing this. So typically when I do these design sessions, I'm putting stuff on a whiteboard, I'm typing stuff on a computer. We have people in the room, not just developers, but designers, domain experts, everybody. And we're trying to build a shared mental model. The goal is to build the shared mental model. And it's an interactive process. So I'm typing things on the board. And as part of typing, we're all learning what these concepts mean. What does it mean to deal a card? What does it mean to have what is a suit, or what do these things mean? So we're talking about what they mean as I type them up. So I'm going along and I type in something like this. To deal, we have a deck, and the output is a new deck, and so on. And one of the domain experts might say, that's actually not right. When we deal in a card game, we normally deal with a shuffled deck. So I say, okay, let me just change the design to represent that. So we now deal with a shuffle deck. And then I'd say, okay, they say, well, yeah, that's right. And then I will say, okay, what is the shuffle deck? Because I don't know anything. So I'm asking questions, and they say, well, it's a list of cards. Okay, so I'm writing down that a shuffle deck is a list of cards. And notice that I'm not saying it's a Boolean flag on the original deck. It's a different concept. A normal deck and a shuffle deck are different concepts in the domain. They need different definitions. Even though they might be represented by the same thing behind the scenes, they're actually different concepts. Okay, so we need to keep them separate. Okay, now as a developer, I say, okay, how do I construct one of these things? How do I make a shuffle deck? And they say, well, you shuffle. So they're me asking kind of dumb questions, and they're being very patient with me and explaining how to do a shuffle. And so I learned that a shuffle is when you start with a normal deck and you end up with a shuffle deck. So these things are obvious to the experts, but they're not obvious to me if I've never played a card game before. So the idea is that as I do this, I'm documenting everything, but I'm also learning about the domain. I'm becoming more of an expert in the domain. So this happens very quickly, very interactively, and I'm not writing code, but I am writing code because this is the kind of input for our domain model. So our final version looks like this, and we have the new version of shuffle and the new version of deal, and we have some extra stuff at the bottom, which I learned very quickly. And the goal here is this is domain driven, okay? Everything in this file is to do with the domain knowledge. There's nothing to do with databases, for example. There's nothing to do with foreign keys or joins or anything. Everything in here is something which is domain specific. Okay, and the domain-driven design people have a concept called persistence ignorance. Means you design your domain without caring about databases, because obviously in a real system you're going to have to store the data somewhere, but that's not part of the domain. That is something else you deal with in the implementation, but it's not part of the domain model. Now, this is not object-oriented driven. There is no base classes, there's no managers, there's no factories, there's no visitor pattern, all that stuff. Again, it's not relevant to the domain. So in the real world, we have these concepts, and what we want to do is have the same concepts in our code. Okay, every time we learn something in the real world, we represent it in our code. It needs to be in sync. So let's say we learn about a shuffle deck, then our code should have something called a shuffle deck. Okay, so that's very, very important that the code is always in sync with our knowledge about the real world. It's a one-to-one connection. Now, what we shouldn't do is the other way around, where we say, oh, we need to have a controller to manage all the players, or we'd say, oh, the deck and the shuffle deck, they have a lot in common, so let's make a base class, or we have an abstract card, proxy, factory bean. These things are not part of the domain. They might be part of the implementation. Obviously, the implementation can get complicated, but that's not part of the domain logic. So we shouldn't have them. So one of the goals in Agile is that the domain, the best way to document your code is to use the code, because the code never gets out of sync. The code is version controlled. The code is guaranteed to be up to date, unlike documentation. So if you can have good design and have your code represent that design, that is the best way of doing documentation. So again, this is not pseudocode, this is executable code, and like in an F# project, this is typically the first file in the project, and all the rest of the code kind of uses this as the interface or the definition of all the inputs and outputs for the rest of the project. So, and again, it's not just about the result, it's about this process of building a shared mental model, okay? So I can't stress this enough. Building the shared mental model is the most important thing. The code is just a side effect, but you've got to have everyone on the same page. Otherwise, you're not going to have a successful project, okay? So you need to collaborate with people who aren't developers. So here's our key domain-driven design, which we're going to use for the rest of the talk, which is communicate the design in the code. That is the main thing to remember, okay? You've got to communicate the design in the code. So before we move on, are there any questions so far about what I said? Please write them in the chat if you have any questions. I'll give you a minute. Nope. I don't see anything in the chat, so I will keep going. But if you do have a question, feel free to put it in the chat. And when I get to the next stopping point, I will answer all the questions that you have so far. Right. Okay. So I'm going to give you a little challenge here. And I'm going to ask you to look at this code. This is F# code. I'm going to ask you what is wrong with this code. Is the design communicated in this code? So we said that was one of our rules. If you saw this in a code review, would you be happy with this code? Or would you make changes? And if you were going to make changes, what changes would you make? So to be honest, I would have been quite happy with this code a few years ago. And as I've learned more about domain-driven design, I am now unhappy with this code. And so I am going to change, I'm going to show you all the ways that I'm unhappy with this code and what I would do to change it. Yeah, so the email verified property is not very good. It's culturally constrained. Having a middle initial is a very American thing, and that is true. And holding of the first name and the last name is a very Western thing as well. There's no primitives, right? And middle initial could be optional. That's absolutely right. So yeah, let me tell you. So these are very good answers you've got so far. Let me tell you the kind of things that I'm talking about. So yeah, which ones are optional? So for example, the middle initial might be an optional thing. It's a very American thing and very Western thing. It's like most people don't care, and you might not have it. And it's not at all obvious whether it's optional or not. Now, you might say, well, I have some validation logic somewhere that checks, that's allowed to be null, but the first name is not allowed to be null, and I'm going to check it somewhere. Well, yeah, you can check it somewhere else, but it's not obvious from this design. Is it optional or not? What I want to do is make it really, really obvious from the actual code. That's what we're going to try and do. What are the constraints? So, the first name, strings can be like 1 million characters long. Can the first name be 1 million characters long? Can it have non-printable characters? Can it be just nothing but spaces? I don't know. Probably not. It's not at all obvious what's allowed. Like the email address, can the email address be any string? Or does it have to have an @ sign in it or something? Again, it's not at all obvious. So for example, I might want to say, well, the name has to be no more than 50 characters because I'm going to put it into some legacy database. Or I just need to print it out on the screen, or I need to print it out on an envelope, a mailing label or something. There's always some sort of constraint. It's really unusual when there's no constraints whatsoever. And the email address has to have an @ sign and so on. So the constraints are not documented at all anywhere here. Now, what's the domain logic? Here's another one. This Boolean flag, when should it be true? When should it be false? It's not at all obvious. When is it allowed to be true or allowed to be false? It's not at all clear. And again, that's not very good. So yes, someone says it should be a choice between verified and unverified. That's a much better example. It's like Booleans are always a bit of a code smell. You should probably never use Booleans in your code. So we're going to address all of these problems later on in the talk. Now, there's a bit of logic here which says that if you change your email address, you have to set it to false, and it's only allowed to be set to true if you have actually verified your email. And that's a bit of business logic, and that's not documented. That's not at all obvious from this design. So we're going to fix that. But here is the problem. This design does not communicate important decisions. It doesn't really tell you anything, right? I would say this is a badly designed piece of code right here. So all these things, which is optional, what are the constraints, what's the logic, we are going to fix them all in the next 60 minutes or so. We're going to use the domain modeling, and we're going to communicate all these decisions in the design, not in some separate validation piece, but actually in the design. And I'm going to show you how to do that. Right. Any questions before I move on? So what I'm going to do now is I'm going to explain functional programming for people who aren't familiar with functional programming. And in particular, I'm going to talk about the type systems in statically typed functional programming, like F#, like Haskell, like OCaml, like Scala. So if you're using JavaScript or Clojure or Elixir or something, this is not really relevant, but it's quite important to the kind of stuff I'm talking about here. Okay, can we say we need to break things down to the smallest things or verbs? I'll address that when we ask me that question later on, and I'll come back to that. Okay, so why am I talking about functional domain modeling rather than object-oriented domain modeling? Okay, so in functional programming, there's some principles which are really useful for domain modeling, I think, which was used in OO, but not as much as it is in functional programming. So the first functional programming principle, which I really want to emphasize, is this use of composition everywhere. And composition is like Lego. So if you know how to use Lego, you know how composition works. So composition means making big things from small things, right? So here's a really, really big piece of Lego made from a bunch of small pieces of Lego. So hopefully you know how that works. So in functional programming, we have the same kind of thing. We have something called an algebraic type system. And that's a kind of mathematical word, so I prefer to call it an algebraic type, not algebraic, but a composable type system, because an algebraic type system is a composable system where you can build bigger things from smaller things. But let me show you how this actually works in practice. It kind of sounds theoretical. So in a composable type system, we build bigger things from smaller things. We build bigger types from smaller types by using and by using or. Okay, so what do I mean? What does that even mean? So let's start with and. Let's say I want to model a fruit salad, and I say, well, a fruit salad has an apple and a banana and a cherry. Okay, so I had to have one of each of those three things. So in F#, I would model it like this, with 3 fields. This is a record with 3 fields. And in F#, we call them records. You could call them structs. You could call them data transfer objects. You could call them dumb objects. They're basically objects that have 3 fields, no behavior, just 3 fields. And in this case, what kind of thing could an apple be? Well, that's another type of all the kinds of things that apples could be. Now, this is anyone who's used any programming language has these things, like C and C# and Java and Python. Everybody has this kind of thing. So this is nothing special. So all languages have this. Now, what about OR? What does it mean to compose using OR? So let's say I want to model a snack. And I would say a snack is going to be an apple or a banana or a cherry. Okay, so it's 3 choices. Now in F#, we model it like this. We use a vertical bar. We say it's a snack is an apple or a banana or a cherry. Right, and we call these choice types. The technical word in F# is discriminated union, and they're also called sum types, SUM, because you add things. So there's different words for these things, but I like to call them choice types because when I'm doing domain modeling, it represents a choice of these things. Now, this is something you don't get in C# and Java. This concept doesn't really exist. You could think of it as almost like 3 subclasses or something, or an enum with extra data. There's nothing quite the same in C# and Java. So this is that we have these choice types and we have these record types. So what do we do with these things? Okay, so that's the kind of theory. Let's see how we actually use it to do something. So let's say that we want to model payments, and we'd have cash and we have PayPal and we have credit cards. And for cash, we don't need any information. And for PayPal, we need an email address. And for credit cards, we need a card type and a card number and an expiry date and all the other stuff. So how would you implement these requirements in your favorite language? If you're an OO programmer, especially. So I think most if people who are coming from an object-oriented background would start off with some sort of interface or an abstract base class or something, and you'd start off with the interface, and then you'd have the three different types of payment as implementers or subclasses of the main interface, like this. And each subclass has its own information, like the PayPal, you need an email address, and for the card, you need a card type and a card number and all the other stuff. So each kind of subclass has its own information, which is important to that subclass. So I think this is typically how most object-oriented people would do this. So let me show you a different way of doing this. Let me show you the functional way of doing this. So in a functional way, we would build bigger things from smaller things, just like the Lego. So we're gonna start off with small things and build, compose them together, combine them together to make bigger and bigger things. So we're going to start off with the small things. We're going to start off with an email address and a card number. And because we're doing domain-driven design, we do not want to use primitives. We don't want to use strings and ints and floats. We want to use words that make sense to a domain expert. So we're going to use the word email address and the word card number rather than the word string, which doesn't mean anything. Okay, so now we have those. We have our first choice, which is that a card type is either Visa or MasterCard. It's a choice. And then the card information is a card type and a card number. So that's an and. So we have an or, which is a choice type, and we have an and, which is a record type. So or and and. We're building bigger things and smaller things. Okay, now let's keep going. Let's build the payment method from the things that we have. So we say a payment method is cash or PayPal or card. So when I'm using the word, every time I say the word or, it's going to be one of these choice types. And the thing that what differentiates a choice type from an enum is that each option can have information associated with that option. So the PayPal case can have an email address associated with it, and the credit card can have some card information associated with it. So that's it's more than just a regular old kind of enum. Okay, so there's a choice type. But the nice thing about using composition is that you don't have to stop. You can build bigger and bigger things from the smaller things. So we say, okay, let's keep going. Let's build bigger things from this payment method. Okay, so let's talk about a payment amount. So that's going to be, we don't want to use decimals or floats. We're going to use payment amounts. Currency is a choice between euros and dollars. So we've got a primitive and another choice type. And then finally, we can say, okay, so a payment is an amount and a currency and a payment method. So again, we're building a bigger thing from the smaller things. We could have a list of payment methods. Absolutely. If we said, it depends on the requirements. If we say a payment, if you can split a payment into multiple payment methods, we could totally do that. Absolutely. Yeah, this is very much like TypeScript. For people who are saying this looks a bit like TypeScript, you can totally do exactly this thing in TypeScript, because TypeScript has the same kind of way of building bigger types and smaller types. So yeah, you can. I say this doesn't necessarily apply to F#. You can use the same techniques in TypeScript, in ReasonML, in Haskell, anything like this. Maybe you need the people paying. Okay, so this is why it's really good to have the domain experts in the room while you're typing this stuff. Like, have I missed something? Have I forgot to deal with the person who's paying? Maybe I need a list of payment methods rather than just one payment method. I don't know the answers, and this is why having the domain experts, the people who understand this stuff in the room while I'm writing this up is really, really important. And they will know the answers. They might not know how to code, but they understand payments really well. So that's why it's really important to have them in the room, and hopefully they can understand this stuff. And they would say, actually, no, I've forgotten to have a list of payments, or I've forgotten to have the person who's being paid, or I've forgotten to have something else which is really important. And they would notice this, and they would give me the feedback, and I could change it as I was typing. And I could do this feedback interactively within minutes rather than days or weeks. So yes, it's very important to get the feedback from the people who know what they're talking about, because I'm not an expert in payments. I'm just a programmer. Okay, so, but the point is here is you can build bigger things from smaller things, and we can use this payment to build even bigger things, right? Just the Lego analogy, we can make bigger and bigger things from the model that we have so far. So that's the benefit of composition. That's why a composable type system is so useful. Right, so Lego everywhere. Right, any questions about this before I move on? So yeah, so I think I answered all the questions about getting the domain experts involved is really important. Yeah, don't just assume that this is the right model. But I think you can see that this code is easy enough for a domain expert to look at and give you good feedback on it, even if they don't understand F# or TypeScript or whatever it is. So it's the process of interactively building the shared mental model. And by doing this, everybody in the room, everyone who participates, understands what a payment is. By showing this to you, hopefully everyone listening, let's say that this was the definitive thing, everyone who's watching this will say, okay, now I know what you mean by a payment. You mean this and this and this. Okay, so that is the idea of what types are. So having static types is very nice in a programming language. So let's do some real domain modeling with these composable types. So I had this challenge about how to fix that contact, and I said there were a lot of problems with it, and let's see if we can fix those problems. Okay, so here we are. Here's our contact definition, and we've got 5 fields, and they're all strings and booleans, and there's no, it's not very clear what the design is. So to me, this looks suspiciously like database-driven design. It looks like this looks like somebody took a database table, and turned it into code, and that's not a very good idea really, because it's not a domain model. It's a database-driven design, which is fine sometimes, but it's not domain-driven design. So let's refactor this to make it more domain-driven. All right. So the first thing is, when I talk about a contact, in the real world, I wouldn't say that a contact has a first name and a middle initial and a last name and an email address. I would normally say that a contact has a name and an email. That's how I would say it when I was just talking. So immediately, I should really write it like this. A contact has a name and an email. That's a much better way, because that's how we talk about it. So immediately, I've broken it down into concepts which are more relevant for the domain, right? So we've got 2 new concepts already that we didn't have a minute ago, but this represents the domain much better than it did already. Okay, now I would say, if I'm doing a domain, if I'm actually doing a workshop, I say, okay, so what do you mean by a personal name? So we say, okay, a personal name is a first name and a middle initial and a last name, okay? And then I want to say what's required and what's optional. And they say, well, the first name is required and the last name is required, but the middle initial is optional. Okay, so how can we document that in our design? How can we make the optional part explicit? So if you think about optional values, when we say something's optional, we might say it's either present or it's missing, right? It's either something or it's nothing. So let's just take that. We're going to say optional value is either something or nothing. And notice it was something or nothing, so we're going to use the vertical bar. It's a choice between something or nothing. Now, if it's something, there's some data associated with it. And if it's nothing, there is no data. So there's 2 choices. right? Something or nothing. So our choice type is already helping us to model optional data. Rather than using null, we're using a type that's, that we can create in our own language. Okay. So that's why, and almost all functional languages have this built in, but if it wasn't built in, we could build it ourselves really easily because it's just another choice type. Now in F#, this is actually a generic type. And in F# we use a little tick to make it a generic. If you're using C# or Java, you wouldn't have the tick. And I don't know how you do it in TypeScript. But it's the same idea. It's a generic type. It'll work. The optional can be an optional int or an optional string or an optional boolean, anything you like. Right, so now we can write our personal name with an option. And so what we're going to have is a rule that everything is required. All the data is required unless we mark it as optional. Okay, so the first name is required, the last name is required, and the middle initial is now optional. And we've indicated that in the design. And the nice thing in F# is you can actually put the optional afterwards, and it makes it a little easier to read for people who are not programmers. It makes it a little cleaner, I think. But they're both the same. So that's the nice readable part of that. Okay, that's part one. Now, what about these constrained values and these simple values? It's very important, and I said this before, it's very important to avoid something called the primitive obsession. So primitive obsession means that everything is done with strings and ints and floats and booleans and stuff, right? Do not model things with that. I was in a workshop once and somebody said, I said float, and they said, does float have something to do with water? And it's fair enough, because that's what most people think it means. But no, it doesn't mean anything like that. So don't use those words, okay? We should use words that mean something to the people. We should use words like payment amount and email address and, whatever, things like that, okay? And on top of that, it's really unusual to have a completely unconstrained integer or a completely unconstrained string. A string that can have 4 billion characters in it, or an integer that can be up to 4 billion or whatever. It's really unusual. I mean, it does happen sometimes. But for example, an email address can't be empty, and it has to have some sort of pattern. And a phone number is not just a string, it has to match some sort of pattern. And even something like a custom ID, if it's database ID or something, it actually has to be a positive integer, right? So it just can't be anything you like. And email addresses are not just strings. Custom IDs are not just ints, because you can tell, because you can't treat them like strings. Like if you add 2 email addresses together, does that make another email address? No. You can add 2 strings to make another string, but you can't add 2 emails to make another email address. That doesn't make sense. A custom ID, you can't multiply a custom ID by 42. You can't take the square root of a custom ID. It's not an integer. It might be represented by an integer, but it's not actually an integer from a domain modeling point of view. Okay, it doesn't obey the same rules as an integer. So we're going to use wrapper types to keep these things separate. Okay, so rather than just having an email address be a string, we're going to make it a wrapper around a string. And rather than having a custom ID be an int, we're going to have it be a wrapper around an int. Okay, and this is how we do it in F#. This is how we do it. All languages have different ways of doing it, but this is the way we'll do it for this talk here. So we're going to wrap it a string, or we're going to wrap an int. Okay, so these are no longer strings and integers. These are now separate types, which are distinct. And here's another one. You can have rather than just a regular old string, we can have something called a string 50. So it has to be 50 characters long at the most, right? So you can even have something like that. So that's constrained to be a certain length. So what's interesting is when you do this and you take a wrapper around an email address and a phone number, as soon as you do this, these are now distinct types and they can't be mixed up. Like if you pass one, you can't pass the other one as a parameter by mistake, or use one by mistake in the other one. You can't compare them by mistake. They are completely different things from a coding point of view. Similarly, if you have an order ID and a custom ID, they might both be integers behind the scenes, but as soon as you do this, they become distinct and they're no longer the same type. So you can't compare them. You can't accidentally mix them up. So this is really, really good. I like to do this a lot. And there's two benefits. The first benefit is it's much clearer from a domain modeling point of view. These types are much easier to understand. Rather than talking about ints and strings, I'm talking about customer IDs and phone numbers and payment amounts and stuff. And from a coding point of view, it reduces quite a few bugs because you can't ever mix them up by mistake. So two benefits. It's really nice to have both benefits in one go. All right, so let's look at how you actually write code that would construct one of these things. So we can, I think it's an interesting lesson here. A lot of people would say, okay, I want a factory function or a constructor function that will create an email address, and you pass it in some sort of string. And if the string contains the @ sign, then I'm going to wrap it in the email address. But what happens if it doesn't contain the @ sign? What should we do? Should we return null? No, we shouldn't. We shouldn't return null. Should we throw an exception? No, we shouldn't do that either. It's just bad form. I'll show you in a minute what the right way to do it is. One of the reasons for not throwing an exception is that if you throw an exception, if you look at the signature for this function, it will say you give me a string and I'll give you back an email address. That's what the function signature will say. And that is actually a lie, because if you give me a string, I won't always give you back an email address. Sometimes I'll throw an exception, or sometimes I'll give you back null. So this is actually a lie, and we really try to avoid this kind of thing in functional programming. We like everything to be explicit, okay? So we try not to have lying code. We try to have our code be kind of self-documenting. So if you want this code to be self-documenting, how can we fix this implementation? Well, we're going to do this instead. We're going to say, if it contains an @ sign, I'm going to give you something back. But if it doesn't contain that sign, I'll give you nothing back. So we're going to use the option type that we just talked about a minute ago. Now, what's interesting, if you look at the signature for this function now, it says you give me a string and I might give you an email address back. Maybe, if you give me the right kind of string. And if you don't give me the right kind of string, I won't give you an email address back. So this is a much better documentation for what this function does. I don't have to like look inside the documentation. I don't have to look at the how it works, the implementation. I can just look at the outside and I can see immediately what it does. So this is much more explicit, and as functional programmers, we like to write this kind of code much more than we like to write the code where you have to kind of guess whether it works or not. So we can do the same thing with string 50. You give me a string, and if it's less than 50, that's good, and if it's more than 50, that's bad. And again, if I look at the signature, it says you give me a string and I might give you back a string 50. And again, it's really obvious that it might work and it might not work. I don't have to guess about what it's doing. Here's another example. Here is an e-commerce site, and I have 999,000 items that I'm buying. And this is probably a bug. I don't think any site allows you to buy that many items. I don't think Amazon allows you to buy 1 million items of anything. Probably it's a bug because the person who wrote this code used an integer, right? They didn't use a special type. They used an integer, and integers can get very high by mistake. So this is a bug waiting to happen. So don't use integers to represent these kinds of things. So what can we do instead? Well, let's use a wrapper type, okay? We're going to wrap an integer with a special thing called order line quantity. We're going to spec a whole new wrapper type just for this one particular reason, for this particular case, because it's not an integer. Again, you can't take the square root of it, right? And you don't normally multiply it. Typically, with this thing, you add 1 to it and you subtract 1 to it, and that's about it, right? Now, a lot of people wouldn't be bothered to do this. They'd just use an integer. But if it's a one line of code, it's a lot. You're going to do it a lot more often. So I definitely think having a language which makes it easy to do this is you're more likely to do it. But even in Java, I would probably do this because it's going to reduce some bugs. And let me show you the kind of bug it will reduce, it'll get rid of. Here's our constructor again. And if it's between 0 and 99 or 1 and 99, that's good. Otherwise, it's bad. And if you look at the signature again, whoops, it says you give me an integer and I might give you back an order line quantity. It might work and it might not work. Now, what's interesting about this is that 0 is not allowed. So if you give me 0, you will not get back an order line quantity. So if you have one of those buttons where you kind of click the minus button and it goes from 1 down to 0, you are going to have to handle the case where it goes to 0, because your code will not compile otherwise. So the case where it goes above 100 or it goes below 0, below 1, your code is forced to handle that case. You cannot accidentally forget about it. So this is what I mean by you can actually eliminate certain kinds of bugs that you might have otherwise if you didn't do this. Like you might say, well, I'll write a unit test to make sure it never goes below 0. Or I might write a unit test to make sure it never goes above 99 or whatever. But you might forget, you might have a bug in the unit test, or you might forget to do it when you change things. This guarantees that this will never happen. You literally cannot have a situation where you have the bad data in it. So let's look at the challenge after the first refactor. So this is what we had before. So we're going to use optional values. So that's one thing. And the next thing I'm going to do is use these constrained types rather than primitive types. Okay, that's much better than what we had before. And we've broken it down into 2 sub-pieces. We've got personal name, we've got email contact information as 2 separate things, which is much more relevant to how the domain works. So if you're doing domain-driven design, this is what we call aggregates or consistency boundaries. So, but I'm not going to go into too much detail with that. Right, any more questions? So we covered quite a lot here, but and we haven't even finished yet. This is just the beginning. We're going to get more complicated, but this is I think already it's looking a bit nicer than it did when we first started. Any questions about this, anyone?
I think you have some question in the...
Oh, I see. There we go. Yeah, so I just wasn't scrolling down. Here we go. Oh yeah, there's a whole bunch coming through here. You don't have information about the error. This is true. When I'm constructing in these constructor classes here, if it doesn't work, let me go back up here. If it doesn't work, I'm just saying it either works or it doesn't work. I don't know why it didn't work. And so, yes, if I wanted to have more information about why it didn't work, I could do it in a different way using a result type or using an either type, where you could actually have some extra information in the error case rather than just saying nothing. You could say it was an error and this is the reason for the error. So yes, I wasn't going to get into it in this talk because it makes things more complicated, but yeah, you can totally have a better error handling than I've got right now. Yeah, I'm not going to talk about error in this talk, I'm afraid. What else? Is it leaning towards a DSL? Not really a DSL. It's all about just making the code represent the domain better. I wouldn't say it's a specific domain language. It's just, but it is using the vocabulary that a domain expert would use. Yes, none is not always an error. That's right. Yeah. So yeah, the whole thing of error handling, I have a whole talk called Railway-Oriented Programming, which is all about error handling and about using the result type or the either type to document the kind of errors you can get. But at this point, I'm not gonna talk about it in this talk. I don't think it's just too much to be too much information in one go. Anything else? Why do we have option of order? I'm not, Vincent, I'm not sure if I understand the question here. Why don't we have an option of order? I think it says Vincent's left the meeting. Maybe he lost the connection. I'll tell you what, I will keep going, and if you've got more questions, I will come back to them at the next step here. Okay, so let's move on. And we talked about options, we talked about wrapper types, and we talked about breaking things into smaller chunks, which are more relevant to the domain. Now we've got one more thing, which is I'm going to talk about getting rid of Boolean flags. And here's what we have with our email address contact information. We have this email address, which is now a wrapper type, and we have this Boolean, is it been verified or not? And we're going to try and get rid of the Boolean because, as I said, Booleans are ugly and they don't document the domain very well. So how can we get rid of the Boolean? Now, if we go back to the requirements, what are the requirements for this flag? Okay, what is this? What are we going to have to do here? Well, there's some business rules here. One of the business rules is if the email is changed, the verified flag has to be set to false. Okay, because we don't know that you're verified. And if you have been verified, you get the verification email and you click on the link and that proves that you own the email. Well, that proof should only go through a special verification service. It shouldn't be able to be set to true by anybody because that might be a security risk. It should only be set to true by a special system service, right? So how can we capture these rules in our design? As it stands, anyone can set it to be true, even if they forget to read the documentation or they deliberately, maliciously set it to be true, because they're a bad person. So let's fix that. When we say something like this, an email address is either verified or unverified. Let's listen. They're using the word "or," right? So we're going to model it as a choice. It's either unverified or verified. And if it's unverified, we can use a regular old email address. But if it's verified, what do we have in that case? So I would then go to them and I say, is there anything different? Is there something special about a verified email? Okay, so in the unverified case, that's fine. We can use a normal email address. But what about this verified case? What goes here? Let's ask. So I don't know. Let me ask somebody. Let's ask a domain expert. They're the people who understand the system much better than I do. So I would say, is there something special about a verified email which is different from an unverified? Are there business rules or something which is different for each one? And they might say, yes, it's really important that you don't mix up verified emails and unverified emails. Just like with the card game, it's really important that we don't mix up shuffle decks and normal decks. Like shuffle decks are special, and they're not the same thing. They might both be a list of cards, but they're different. Just like an email address, a verified email and an unverified email, they might both be strings, but they're different things. They're used in different places. So how are we going to say that it's different? We're going to wrap it. Okay, we're going to create a wrapper around an email address and call it a verified email address, just like we did with shuffled deck. We're going to say a verified email is different from a normal email. It's a different thing. Okay, and I like the slogan, there is no problem that can't be solved by wrapping it in a different type. So this, again, wrapping, we've got a type wrapped in a type wrapped in a type already. So that's what we put in our verified case. Okay. So now, in order to create the verified case, we're going to have one of these verified emails. Okay, so hopefully this makes sense. Now, let's see, where do we get one of these verified email things from? Okay, well, we said that we have to get them from a special service. Okay, we said there's a special verification process that does this. So let's model this. Okay, so the input for this verification service is a regular old email, and the output is a verified email. So you give me a regular email address, and you also give me some sort of hash or something, the code to check the verification, and I might give you back a verified email. Again, it's very clear that it might not work if the hash doesn't match the email address. It is valid, or maybe the time's expired or something. There's various reasons why it might not work. It's very clear from this design that it might not always work. You'll have to deal with a case where you don't get a verified email. Okay, so that's our verification service modeled as a function. Okay, so now we have everything we need to know to model the whole thing. So we have a verified email, which is a wrapper around a normal email. We have a verification service, which takes a normal email and gives you back a verified email, maybe. And now our main contact information is a choice between unverified and verified. Now, if you think about the business rules, let's look at this. In order to create an unverified email, we can use any old email address. That's fine because there's no special rules around that, because you change your email address and you have an unverified email. You have to set it to be the unverified case. Now, when we want a verified email, in order to create that case, we have to have the verified email object. Where do we get one of these verified email objects from? Well, the only way you can get one of these verified email objects is as the output of this verification service. And you might say, well, I could create it some other way. What we can do is just use what we do anyway, which is have a private constructor. Just like you do in object-oriented programming, you'd have a private constructor and have some way where this is the only factory method, as it were, that can create one of these things. So you can force people down this route. So the only way to create a verified email is as the output of the verification service, which is exactly what we wanted. That's exactly what the business rule was, right? The business rule said you can only be verified if it's gone through a verification service. So we don't need to have a special validation or any kind of rules to check the business rule, to check that this logic is being followed. The logic is followed because the design will not let you write anything that doesn't follow this design. So you literally cannot get it wrong. If you have this design, you cannot make a mistake in your code. And I think that's really, really cool. Yeah, here's another example: sanitized strings and unsanitized strings, escaped output. Yeah, so you could have anything. These choice things are very useful. Unescaped string and an escaped string. And the only way you can get an escaped string is to run it through an escaping service. And you guarantee that this escaped string has been properly escaped because it has to have gone through the verification service or the escaping service, or whatever. So this is a really common pattern, and it's really, really useful. But it's really nice because I don't have to go to the documentation to see what the business rules are. And I don't have to have unit tests. There's no point even writing unit tests because I can't compile code that fails the business rules. I literally can't even write the code. So I think that's pretty amazing. I think that's pretty awesome. So if we go back to our challenge now, we have all these different things now. We started off with one. At the beginning, we had one thing, and now we have an email address and a verified email and a choice between unverified and verified and a personal name and a string 50 and a contact and all these things and and a service and stuff. We now have 6 or 7 things when we only had one thing. So what the values are optional, that's now, if we look at the rules, what things are optional, what are the constraints, what's the domain logic? Well, which things are optional is much more clear. It's literally staring me in the face. I don't have to look at the documentation. I don't have to look at any validation logic. What are the constraints? These things are constraint types. Again, I don't have to check the documentation, right? Which fields are linked? It's really obvious. These are domain concepts now. And is the domain logic clear? Yes. The concept between a verified and unverified is much clearer now than it was when we had a Boolean. And so not only is this a better design in terms of being less buggy, but it's a better design in the sense that the vocabulary represents the actual domain. In the original version, we just had one word. And it turns out that the domain actually has a lot of different words. The domain experts have a concept of an email address. They have a concept of a verified email. They have a concept of a personal name. These are concepts which is important to capture in your code. So even though there's more concepts in the code than there was at the beginning, these are all important concepts. These are not accidental concepts. These are important concepts that we should capture in the code because they're a very important part of the domain. And so therefore our code should represent them. And again, this is compilable code. This is not documentation. So I think, like I say, this is really, really useful way of doing domain-driven design. And one final thing, and then I'll take some more questions. In the domain-driven design world, we have a thing called refactoring towards deeper insight, and that means that when you do this kind of learning, you often as you create new pieces of vocabulary, you learn things about the domain that you didn't realize before. So for example, let's say we had a business rule where you can only send password resets to people who have verified emails, right? That's a very important rule, because otherwise it's a security breach. Now, before we had our domain, the original domain model, we would say, okay, we have sending a password reset, and you pass me an email address, and then I have to check whether the email address is verified or not. And if it is verified, I can send the password reset message. And if it's not verified, well, that should never happen, because you're never supposed to call it. And of course, you know, every time you see this should never happen, one day it will happen. So this relies on people checking things properly everywhere we do this. And yeah, you can say, well, I should check it, but one day someone's going to forget to check it, and they're going to have a bug, and it might be a really serious bug. Now, once we have this concept of a verified email, we have this new concept that we didn't have before. Once we have this concept, we can change our password reset, and you say this takes a verified email as input. Now, as soon as we have that, we don't have any checking inside this code anymore, because you literally can't. There's nothing to check. It's a verified email by definition. So the code actually becomes simpler. There's less defensive programming. There's less branching. The very fact that we have this new concept called a verified email, it turns out we can use this concept in some other place that we didn't think about at the beginning. So this is the value of doing this, not just about representing the domain, but actually learning. As you represent the domain better, you actually learn things about the domain that makes sense. It makes other things in the domain easier if you do it right. So there we go. No validation needed anymore. You can't have a bug in this code anymore. Right, any more questions before I move on to the last section here? I've got another 5-10 minutes to go, and then any more questions, anyone? I don't see anything in the chat. No? Okay. Oh, what does this start to look like on the boundary of the system? That's a very good question. Typically, all this validation stuff, like, returning optional things, that happens on the boundary of your system, where you get what's coming in is JSON or XML or something you don't necessarily, you're reading from a database, you don't necessarily trust the input. So you do a lot of this validation on the way in. You validate your JSON and you create these objects from your, from the input. Now, at that point, everything's optional. It's like, well, we might or might not have a valid email address. We might or might not have a valid, verified email, whatever. But at that point, if it wasn't valid, then we'd say, okay, we have to exit the whole function or exit the whole workflow or story, because we don't have valid data. But what's interesting is if we do have a valid email at that point, we never ever have to check it ever again in the rest of the code, because it's immutable, which means nobody can change it. And once it's been wrapped in this type, I guarantee if it's wrapped in this email wrapper, it's going to have an @ sign in it. It literally can't be a bad data. So we actually eliminate, it can't be null. These wrapper types mean that you actually reduce your defensive programming. So everywhere, there's a bit of work at the beginning at the boundaries where you have to do the validation. But after you've done the validation, everywhere else in the code, you never have to do any defensive programming. You never have to check again, is it still valid? Is it null? Is it too long? Is it too short? Does it have the right constraints? Or that never has to happen. So yes, there's a bit of a penalty on the boundaries, but the rest of the code, there's no penalty. How do you know whether you should use options or discriminated unions? Every time you use the word or. So if someone says it's verified email or it's an unverified email, they're using the word or. So that's a discriminated union. And an option is just a discriminated union where it's either something or nothing. So yes, you could have a record with values which are all options or discriminating. Yes. Is there a sample web app we can look at that uses these principles? Not really, but if you, I'll talk about that at the end. Let me just finish the last few slides, and then I can have an open question. All right, so the last bit is I just want to do some more detail on how you can do business rules with types. So let's say that sometime later we have an address. Okay, so as well as having email, we have an address, and we have a business rule that says somebody has to have an email or a postal address. Now, this is design that I have right now does not meet the requirements because both fields are required, right? We said that all fields are required unless you say they're optional. So this, as it stands, does not meet the requirements because it doesn't say you have to have both of them. So you might say, well, okay, I'll make them both optional. But that doesn't meet the requirements either because they could both be missing. And then you might say, well, okay, I'll put some validation logic somewhere else that says, well, if they're both missing, that's an error, and I'll throw an exception. And I think you know that I'm going to say that's a bad idea. I don't want to do that. I want to try and document the choices in the design itself, right? So rather than having them both be missing and then have some validation logic, I want to try and make sure the design does not even allow them both to be missing. So, okay. So how can I do that? How can I make a design where it can have one or the other, but they can't both be missing? Okay. So this quote, make illegal states unrepresentable, means you cannot even write code that does the wrong thing. So rather than having them both be missing and then validating it, literally write it so you can't have them both be missing. So if you think about it, when we talk about the requirements, we say, well, it has to have an email address or a postal address or both. Notice that we're using the word or, and there's three choices, right? Three choices, and we're using the word or. Well, I think that tells you how we can write the design, right? We're using the word or, we got three choices, so we're going to have a design which is a choice type, and it's going to have three choices. And the first choice is just email only, the second choice is address only, and the third choice is both of them. And the fourth choice, where they're both missing, is not even available. So it literally cannot have a choice where they're both missing. And what's nice about this is you cannot make a mistake. I cannot have a situation where they're both missing by mistake. It's also documentation. Again, if I come on as a new developer and I look at this code, I don't have to look at the documentation. I can actually look at the code and it tells me what all the choices are. So it's self-documenting code. We've got the requirements in the type. You can't even write a unit test to test it because the unit test with them both missing, you can't even compile it. So I think static types are awesome, almost as awesome as a cat on a unicorn. Not quite, but pretty good. Now, just one final thing about collaboration. When I'm doing these workshops, it's okay to push back as a developer, and you can say, we could design it this way, but let's think of it as a better way of designing it. If the business people say, I want to have this or this, is that really what they want? And you can say, that way I just did it. I can do it that way, but it's kind of ugly, and it's only going to get more ugly if we add new kinds of choices. So it's a kind of rigid implementation. Let's look at a more flexible implementation. And how about this? A contact has at least one way of being contacted, right? Which is basically the same thing, but it's not exactly the same thing. And I think this is a better design, and the business people will probably be quite happy with this too. But from a design point of view, it's the code, the design is much easier because we say, well, here's the different ways you have been contacted. We can contact you by email. We can contact you by address, and then the main contact information is there's a primary way and a secondary way, and the primary way is required, and the secondary way is optional, and that really captures the same kind of idea No, it's not exactly the same because you could have two emails or you could have two postal addresses. So it's not exactly the same, but it's good enough. And what's really good about it is, as things evolve, you add Facebook or you add texting or you add Twitter, whatever, you can keep adding things and it's not going to break all your code every time you do this. So this is a much nicer design. So let's just summarize and then I'll take some more questions. So the thing I really want to emphasize is we're trying to represent the shared mental model in code. And I really want the developers to become domain experts, right? The idea is that the code and the code is trying to represent the same words, the same concepts that the domain experts have. And we're writing this kind of collaboratively, right? It's not just the developers deciding on something. We need to talk to the people who understand the business. And designs evolve. This is not meant to be like a big design upfront thing. This is meant to be a design that can change as you add new features or as you learn things. You just tweak, you evolve the design. You add new things as you learn new things. It's not meant to be a big, heavy design. It's meant to be a flexible design. And often as you learn new things, you will refactor the design and it becomes better. The more you refactor, just like with anything else, the more you refactor, the better it becomes. And the nice thing about using static types is that when you do make these changes, everything breaks, which is annoying, but you fix all the errors that happen when you make a change like this. And you spend maybe an hour, going through all your code, fixing up all the errors. But when you have fixed up all the errors, almost certainly it's going to work. You're going to trust that the code still works. Unlike with a dynamic language like Python or something, or JavaScript, you make these changes and you're never really sure, have I accidentally broken something? So that's, I think static types are much nicer for this kind of thing. So composable type system, how I said, I think this is much nicer than the object-oriented model because we have these choice types, which are fantastic. We can use optionals rather than null. We use a lot of these wrapper types all the time. We use one-line wrapper types are really fantastic. And we really try all the time to make illegal states unrepresentable, which now there's nothing you could do this in object-oriented code, but nobody ever bothers to do it. In functional programmers, we do this all the time. So I don't know whether it's just the way about the languages or what, but it's just a different way of thinking about how you do design. So thanks very much. I will take some more questions now, and then I'll just tell you some more stuff. If you do want more stuff, I do have my stuff on my website /DDD. And I have a training coming up. If you want to learn more about this in more depth, a 2-day training course, or it's actually going to be spread over 8 days, I think. But it's it's logically it's a 2-day, it's a 16-hour training course, but it's spread over a bunch of days now because it's online. So any more questions? And what do we have here? Sorry, yes. Is there a more general solution to email address or both? What if there is 10 instead of 2 choices? Yes. So I think I answered that already, didn't I? I think you asked that just as I talked about that. So I think this is the bad way, but as soon as you do this way, as soon as you redesign it, I think that answered that question, didn't it? Could you have a list of contact information? Oh, this is a very good one. People always ask this one. So I have a primary contact information and an optional secondary information. And people often say, well, rather than just having 2, why not just use a list and have as many as you like? And the answer is, that's easy to do, but is that actually, if you have a list of things, how would you represent that in the user interface? Right? So it's not just about whether you can do it from a coding point of view. It's the whole system. You have to think about, can it in your contact system, can people really have an infinite list? Can it be an infinite list of contacts, or like can they have 1,000? So then at some point you're going to have to put constraints on the length of the list now. So it has to be at least 1, but maybe it has to be less than 10 or something. So yeah, you could do that. And but you'd probably have to put, it wouldn't be just an unlimited list, it would be a 1 to 10 list. So yeah, you need to be more, again, asked. I don't know what your system needs. You have to ask the domain experts. And this is where the user interface people would come and handle the user experience. They might say, users do not want to have 20 different ways of being contacted. They just want 1 or 2 or 3, and don't make it more complicated than it needs to be. So yeah, just because you can doesn't mean you should, to quote Jurassic Park. Next question: can you mix a F# domain model with a C# business logic? Yes, you totally can. C# and F# work together pretty well. And so I know people who do that, especially if you have existing legacy C# logic. Yeah, you can be compatible between the two. I mean, typically, I like using F# for everything, but there's no reason why you can't mix them together. Why F#? Okay, so all the code I did here was using F# instead of, I could have used TypeScript, I could have used ReasonML, I could have used Haskell, I could have used Elm. They're all the same idea. I'm F# person, and I like the syntax of F#. I think this is very readable. I think TypeScript is a bit less readable. I think other languages are less readable, and I just like F#. But you could totally do this in other languages. I've seen people do this. Like I say, I would say that TypeScript would be a good candidate for doing this in. Yeah, non-empty lists would work. Yeah, Scala, you could do this in Scala. Scala, the syntax of Scala is not so easy for non-experts to read, because the way they do choice types in Scala, you have to have a trait, and then you have to have objects, sealed objects or whatever it is, case classes. It's not quite as easy to read. But yeah, you could totally do it. You could totally do this. There's nothing special about F# here. Any functional language with composable types would work. Kotlin would work just as well. So I just like to use F# because that's what I'm used to. So what about a functional library in F#? Do you mean using mixing the C# domain logic and F#, or Vincent, I'm not quite sure what, your question here. So what else? I'll just wait for Vincent. You can get back to me on that question. Why do I think F# isn't popular? That's a good question. I think because the C# people, because C# is pretty good, and I think a lot of C# people, they don't feel the need to switch. I think what's interesting, a lot of Java people felt that Java was pretty bad a few years ago, and so they investigated Kotlin and they investigated Scala because they were having a lot of pain. I think C# is evolving, and so C# people felt that they were being, their pain points weren't as bad. But I still think F# is better than C# just because the defaults are different. I mean, C# is getting a lot of nice functional features, but things like immutability and just the default behavior in F# I think is nicer from my point of view. But yeah, you could do a lot of this stuff you could do in C# if you wanted to. It would be a bit weird. The only problem is that if you started doing this in C#, a lot of people wouldn't really understand what you were doing, just because it's a bit weird. But yeah. Oh, is there a functional library like cat or Scala Z? Yes, there is. It's called what is it called? F# Plus, I think it is called. They have monads and all that stuff. F# people tend not to be like the Haskell people with all the monad stuff, but there are some F# people who can do that. And there's a functional library just like cats. I think it's called F# Plus, and it has all the monads and the functors and all that stuff in it, and you can just use those stuff out. But if you know what you're doing, yeah. No discriminated unions in F#. I think it means, yeah, there's no discriminated unions. You can't do this contact information in C#. What you'd have to do is create either probably create two subclasses. But the problem with subclasses is they're not closed. Like subclasses, you can add new ones easily. With this kind of thing, there's only two choices. I believe that in the next version of C#, they're going to add case classes, which is the same thing as Scala and Kotlin have, where you have two subclasses, but you can't ever have a third one. And that way, when you're doing pattern matching, you know exactly it's an exhaustive pattern match rather than just being an arbitrary pattern match like it is currently. So yeah, I wouldn't be surprised if C# in a couple of years, if C# makes this a lot more easy to do than it currently does. Any more questions? I'm happy to stick around for a while if people have any more questions. And I just put this. Oh yeah, okay. Let me see. If another environment something can still be achieved, could you teach this from a Python JavaScript point of view? Yeah, Python and JavaScript are actually quite functional. A lot of the functional programming ideas work quite well in JavaScript and Python to some extent. What you don't have with JavaScript and Python is the static typing. Now, Python has the type annotation extension, and JavaScript, instead of using JavaScript, you can use TypeScript, and you get a lot of the benefits. So yeah, you could do this. I would say you could do this quite well in TypeScript, and you could probably do this with Python if you use type annotations everywhere in Python. But it's not really, they're not really designed for this kind of thing, and I guess that's the problem. You could do it, but there's always going to be leaky abstraction, you know. And then the other question is, I'm curious on how you would handle dynamic choice types. So if there is n, if you don't even know what they all are, at that point I would switch to using object-oriented programming, because object-oriented programming is very good when you just focus on the behavior and you actually don't know what all the choices are. Like in these ones, I know exactly there's 2 or 3 different choices. If I had currencies and I didn't know how many currencies there were, and the currencies don't actually have different, you know, I don't want to enumerate every country in the whole world. At that point, I would probably switch to doing OO. And then another, I mean, on a related question, I just also point out, you can't capture all the behavior this way. I mean, a lot of people say, if we go back to that card game, I can't capture the rules of the card game, like the rules of poker. I can capture some of the important concepts. I can capture the concept there's a deck of cards, and there's a shuffle deck, and there's a hand, and there's dealing, and so on. But I can't capture the rules about how you actually play poker. It's just too complicated. So the same thing, if you're talking about currency trading or something, I can't capture the rules about all the different kinds of ways you can work with currency. I could just say, well, there's a concept called a currency, and there's a concept called an exchange rate, and there's a concept called something, and I'll just leave it at that. And the actual detailed rules, you'll have to have that in the code, you know. Another question: how is the community of F#? It's a really, really nice community. Everyone thinks it's one of the friendliest communities. Everyone's very helpful. And it's very friendly to beginners if you're learning F#. So if you there's an F# Slack, and if you use the F# hashtag on Twitter, people are will be very friendly, and on Stack Overflow. So yeah, if you want to learn functional programming, F# is a really nice community. They're not some people, you know, some other language communities are a bit mean. If you're like, they expect everyone to be like an expert, and they have a lot of jargon. F# people is not like that at all. So I definitely recommend it. Let's see. Let's say, yeah. Thank you for the presentation. I love your book. Thank you very much, Michael. I'm glad you like my book. Here's a link to. Do I have? I don't actually have a picture of my book. Do I have a picture of my book? Yeah, there's a picture of my. Whoops. That's a picture of my book, The Main Modeling Made Functional. It has everything that I've talked about and more. Do we think if statements are a bit of a code smell in F#? No, I don't think if statements are. I would say, I say on my website, if you're learning functional programming, it's probably a good idea to focus on pattern matching and to avoid if statements. But once you actually have them, once you know what you're doing, I don't have any problem with if statements. I use if statements all the time. There's no difference between an if statement and a pattern match on a Boolean. So I'm quite happy to use if statements. I would say in general, Booleans in general, though, are, if you can avoid having Booleans in the first place, that's even better. But sometimes you do have Booleans, and if else is fine for Booleans. For a beginner, is it a good idea to jump into functional programming before learning object-oriented programming? That's an interesting question. I think that functional programming is definitely going to become more popular. I mean, it's already pretty trendy right now. So yeah, I think learning functional programming from the very beginning is good. Sometimes it's easier. Sometimes people have object-oriented programming experience find it harder because they have to unlearn everything they already know. And if you don't know that stuff, you don't have to unlearn it. So it's actually easier. So yeah, I would say it's fine to go into functional programming before learning object-oriented programming. I don't see it. There's nothing you can't do. I mean, I don't think it's going to stop you, from a career point of view, because I think functional programming is kind of becoming mainstream now. What do I think about enterprise functional programming? Yeah, I think I personally think that functional programming, statically typed functional programming, would be really good in the enterprise, because in the enterprise, I even have a blog post called "Why F# is the best functional programming language." So you can Google that. And my reasons for it is that I think that when you're working, the thing about functional programming is all the functions are kind of self-explanatory, like the examples I showed you, and the domain modeling is very good. So I think for enterprise, when you have a lot of different people going through a team, and the people working on it today are different from the people who worked on it a few years ago, and I think it's really nice to have this kind of self-documenting code. So I think it's really good for the enterprise. I hope that they do adopt it. The enterprises are very slow, so I'm not holding my breath. But I remember I was around for when OO was first around, and it took 10 years for object-oriented programming to really become mainstream. I mean, Java came out in 1995. That's how old I am. I'm older than object-oriented programming. I'm pre-Java and pre-Python. That's how long I've been programming. Pre-web. Yikes. So yeah, so I remember when people were complaining about Java, complaining that they had garbage collection, and they were complaining about all this newfangled object-oriented stuff. Why can't they just have pointers and stuff like C did? So I think eventually things will change. It'll change. I think it will take a while, but I think eventually it will change. But who knows? I'm not very good at predicting the future, unfortunately. Yeah, someone linked to my book. Thank you very much for that's my book if anyone wants it. Let's see. Do I have any recommendations or thoughts about the interaction between domain objects and relational databases? That's a very good question. So I said in my thing here, do not, if I go back to a bit of a domain code here. Yeah, so I said don't have anything to do with databases, but at some point you're going to have to put this in a database. And my recommendation is that you have a DTO or a data transfer object, which is specifically designed to be serialized or put into a database. So, for example, the very first definition I have of contact was this kind of contact. Whoops, if I go back up here. Go back to the screen. Probably easier to go back to the... Right, this is what we had at the beginning. So this is really a database-centric model here. So the way I would do it is I would turn my domain model into something that looked like this, and then store this in a database. So there'd be two steps. And this is really easy to store in a database because it's super database friendly. Everything is strings or booleans or floats So this is all the stuff I said about not having primitive types. When it comes to putting things in databases or turning things into JSON, that's exactly what you do want to have. You do want to have everything be primitives, and you want to have everything in one big record, and not broken down into things. So my recommendation is you design types like this, which is specifically designed to be put in a database or to be serialized as JSON, and then you convert in your code at the boundaries of your code, just like you have the validation on the way in. On the way out, you do the same thing in the other direction. You take your nice, beautiful domain model and you turn it into something like this, which can then be serialized or put it in the database. So it's a bit of extra work, but it does keep the database separate from your domain. So I hope that explains. One nice thing about these kinds of objects is that there's no behavior. So unlike object-oriented models, this is just a data structure. And so when you read it and write it to a database, you don't have to worry about the behavior that goes with it. You just literally take some data and read it from the database. So all the behavior is done elsewhere. The behavior is separate from the data in functional programming. So I don't have to worry about deserializing some sort of object. But I don't like systems where they mix database and OO are designed together, like something like in C# there's entity framework, or Hibernate in Java, where you mix the domain model and the database serialization in the same thing. I think that's really bad. I mean, it's okay for small projects, but I wouldn't do that for a big project. Can you have error when you deserialize? Yes. So it depends. So let's say I have a database table, or I have a JSON object that represents this contact, and then I load it from the database, or I load it from a JSON. It's sent to me through a JSON thing. I have to basically revalidate it. Like the email address might not have an @ in it anymore because someone's changed it in the database, or the first name might be null and it's not supposed to be null. It's not allowed to be optional. So I basically, every time I get one of these things, I have to revalidate it before I turn it into my domain model. So yes, it depends on how much you trust your data. I mean, if you're the only person using the database, you might say, okay, I trust it. But in general, I always revalidate data on the way in. It just stops errors happening. So yeah, I almost never trust my data sources, and I always revalidate them. Is there no way to keep constraint on the serialization? Well, in a database, I mean, some databases you can have constraints like that. There are certain rules you can have, but once it's outside your control, people can do all sorts of weird things. Like, for example, a database, you could say it's a non-nullable column. So that's a constraint you can do. But you can't, and you can have a database where it can't be more than 50 characters. But it's hard to, for example, to have an email address that has an @ in it. I mean, some databases you can have those kinds of constraints, but it gets trickier. Basically, don't try and capture the domain model in the database. If you're doing domain-driven, now if you're doing database-driven design, that's a different thing. Go ahead, feel free. But if you're trying to do domain modeling, the database is just an extra source of data. It's not the center of the domain model. So I hope that answers that question. Yeah, if you have an event store. Yeah, so this does work for event store. But again, with event sourcing, your individual events need to be validated, and then you apply the event to the domain model. So again, you still like if you have an event that says the email address has been changed, you try and update the domain model with this new address, and if the new address doesn't have an @ in it, then that event fails. And then you have to decide, well, okay, what do I do if I try to update the system for an event and that it didn't work? It should never happen. It's whenever you say, well, this should never happen. Well, yeah, but what if it does happen? Again, it depends on how much you trust. If you say, well, it really should never happen, and you just say, well, if it ever does happen, I'm just going to throw an exception and crash because it should never happen. That's fine. But if you say, well, okay, I'm going to try and handle it gracefully, yeah. So there's nothing about event sourcing over a database that makes it any special different. Yeah, the event store is immutable. Maybe, yeah, hopefully. So if you do trust the event store to always be good, then you can trust it to always have. If you've put an email address into your event store, and you're reading out again, then hopefully it's all good. What might have changed is your validation rules might have changed, though. Your original, when you put it into the event store, the email address might not have had to have an @ in it, and then later on you decide it does need to have an @ in it. So even though the data is immutable, the validation logic has changed. But that's the whole. This just gets very tricky. I mean, how do you do with schema changes? And event sourcing is even more complicated than just a regular database, in my opinion, because you have to worry about all this stuff. So, yeah, it's not. I don't think I think I would stay away from event sourcing unless you really need it, because it actually adds a lot of complexity to the system in terms of what happens over time. What happens if your validation logic changes over time, or your schema changes over time, and so on. So, but these are all good questions. Thanks, everyone. Yep. Yeah, I mean, I could easily spend hours and hours talking about this stuff. So I'm afraid we've only got, we can't spend all night here, but these are all very good questions. Thanks very much. So Dan?
So, okay. So I think we are done for tonight. So thank you, Scott, for facilitating this meetup. I recall that you will be facilitating 2 training in September, one with Avast Competitor on 4 half-a-day training, and one with HYT for 8 sessions of 2 hours during the after work, 6 to 8 p.m. in CEST time. So if you have any question, I think I have posted in the chat the link for the training with HYT. I had it. For Avast Carpeta, I will let you do some research. So thanks again. If you haven't read the book of Scott, frankly, do it. But if you want to do it in a far quicker and faster way, go to the training. I have done it, and it's really good. This is why we have Scott tonight. So, guys, good evening. Enjoy, and I hope to see you soon. And thanks again, Scott. It was really a pleasure.
Thanks,
Bye.
everyone. Bye. Thanks, everyone.